Good morning, dear students. Today I am explaining the formula. The formula is the distance between the 2 points x1 comma y1 x2 comma y2 is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So how we are finding the distance between the 2 points formula? You see, I consider two mutually perpendicular lines in the plane, that is x-axis, y-axis. Already we studied in our previous classes. So ax1 comma y1, bx2 comma y2 are 2 points in the plane. These are 2 points in the plane. We need to find the distance between these 2 points. Nothing but the line segment to AB. That means AB length. So how we are finding this? You draw perpendiculars from A to A comma B to the x-axis. So you draw perpendicular A to x-axis, B to x-axis. Okay. So this foot of the perpendiculars is where now? This the top is the foot, right? Foot of the perpendiculars I am assuming P comma Q. P comma Q. Okay. Next again I am drawing one of the perpendicular from A to BQ line. A to BQ line. This one I am taking as R. This one I am taking as R. Okay. Coming to here, these are A coordinates are x1 comma y1. A coordinates are x1 comma y1. So here you see this OP is equals to this distance is equals to this same distance now. So nothing but the point of x coordinate. But how we are defining x coordinate? The perpendicular distance from point to y-axis. Point to y-axis. That means this point to y-axis. This is same as O to P, right? So OP is equals to x1. Similarly, OQ is the x coordinate of B. X coordinate is x2. So that is OQ is equals to x2. Okay. Now PQ is equals to what? PQ equals to this one. How I am writing? You see, this one how I am writing? OQ minus OP. So PQ is equals to OQ minus OP. That is x2 minus x1, which is equals to PQ equals to. Okay. Now coming to y coordinates. So y coordinate, how we define y coordinate? The perpendicular distance from point to x-axis. Okay. So A to x-axis, this distance, nothing but AB. AB equal to y coordinate of A. What is the y coordinate? Y1. That is AB is equals to y1. And similarly BQ is equals to y coordinate of B. So that is y1. Okay. You see here, this I am finding here this BP distance. So BP is equals to, how we are writing? You see, sorry, BR is equals to BQ minus RQ. BQ minus RQ. In this total length, if I subtract this one, we are getting this one, right? So BR is equals to BQ minus RQ. BQ minus RQ. This is equals to BQ value we know, that is y2. But RQ is equals to, you see here, RQ is equals to AB. Why it is AB? So this is the rectangle. In rectangle, opposite sides are equal. Understand? In rectangle, opposite sides are equal. So that in place of RQ, we can write AB also. So BQ minus, in place of RQ, what we are writing? AB. this is nothing but y2 minus y1. This is nothing but y2 minus y1. You see here, triangle. In triangle ABR. This is the one of the right angle triangle. Right angle where? At the vertex side. Okay. From the Pythagoras theorem, what we know? AB square is equal to hypotenuse square equal to adjacent side square plus opposite side square. Otherwise, base square plus height square. AR square plus BR square. Okay. AR is equals to PQ, no? Because it is a rectangle. In rectangle, opposite sides are equal. So that AR is equals to PQ. So PQ square plus BR square. Okay. So that is AB square equals to PQ. PQ is equals to what we have here? PQ is equals to x2 minus x1. So x2 minus x1 whole square plus BR. BR is equals to, here BR is equals to y2 minus y1. So you substitute here y2 minus y1 whole square. Okay, now AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the proof of the distance between the 2 points. Okay, so this is the distance between the 2 points. You watch twice, then you will understand easily, and you remember this is the proof of distance between the 2 points. Okay. Now the distance between the 2 points x1 comma y1 x2 comma y2 is we prove square root of x2 minus x1 square plus y2 minus y1 square. Okay. If x2 comma y2 is equals to 0 comma 0, then the distance is equals to what is here? That is x2 is 0, so 0 minus x1 whole square plus y2 is 0 minus y1 whole square. This is equals to square root of 0 minus x1 minus x1 minus x1 square is x1 square. 0 minus y1 minus y1 square is y1 square only. Therefore, the distance between the points 0 comma 0 x1 comma y1 is square root of x1 square plus y1 square under root x1 square plus y1 square under root. If one of the vertices is arching, so this is the formula. Okay, so next already you solved some questions in 10th class. What the given, how we check the given points are forming right angle triangle or isosceles triangle or equilateral triangle or scalene triangle. So these kind of questions we solved in 10th class. Okay, so I'm saying about the types of the triangles. So here, without using these, how we solve? For example, you have to prove the equilateral triangle. So how you prove there? You find all, we find all the sides of the triangle. If all are equal, then it is the equilateral triangle. We concluded that equilateral triangle. Any two sides are equal, then it is the isosceles triangle. If one of the side square equal to sum of the squares of remaining two side squares, so that is the right angle triangle. So everything, the types of the triangles we concluded by the finding the distance between the 2 points. That means we find the side lengths of the sides. How we find? By using the distance between the points. But what I am saying, For everyone, for every type of triangle, we have one shortcut. So, for example, we have to prove the given points are forming a right angle triangle. At the time, what we find the distance between A to B, A to C, B to C, and all the squares. So, which sum of two sides will equal to remaining? We check that one. After that, we concluded that is a right angle triangle or not. Okay, now it is a bit lengthy process, right? So, in next video, I will give you a wonderful trick to, by seeing observing the vertices. No need to write anything. Directly by observing the vertices, we will conclude is it a right angle triangle or not. So, we have a wonderful shortcut. That shortcut we will discuss in next class. Okay.